Okay, so this is a really hard question in regards to factorising, but let's deal with it in the exact same manner as we have before. So let's look at each term individually, and first we look at the numbers and we say, okay, what numbers can go into all of these things? So I know that 3 can go into 36, 3 can go into 63, and 3 can go into 27. So the next thing we need to do is say, is that the biggest that we can think of? Well, I know that 6 can't because 6 times 10 is 60, and if I add an extra 6, that's 66. But I'm thinking, what about 9? Well, 9 can go into 36, because that can go in 4 times. And 9 can go into 63, because that can go in 7 times. And also 9 can go into 27. I'm thinking at the moment that the biggest one I can think of is 9. Okay, let's have a look at the letters. There's a Q in here, a Q in here, but not a Q in here, so I can't take that out. There's a K in here, a K cubed in here, and a K squared in here. Well, that means that the biggest that I can take out is just K, okay, because they all definitely have K in it. This one doesn't have anything higher than K. Here, this one's got R squared, this one's got R squared, and this one's got R cubed, which means the biggest R power I can take out is actually R squared. Okay, so now we're on the stage where we can draw in our bracket. And remember that we do our lines and each line means timesing. So 9 times by what gives me 36? Well, we discussed this earlier. 9 times 4 gives me 36. Okay, I now need to have an extra Q. I've got my K outside the bracket and I've also got my R squared. Okay, so 4Q, if I times that by 9K R squared, gives me 36 QKR squared. Okay, let's do my next term. Okay, 9 times by what gives me 63? Well, that's 7. And here, can you see it's a minus, so we're going to have a minus in front. Okay, I've got no Q terms, but here they've got a Q squared. So I'm going to have a Q squared in here to get that term in there. I've also got a K, but I needed K cubed. Well, that means that I've got another K squared that I need to add in there. And here I've already got my R squared, so I don't need to add anything there. Okay, the last one we need to look at is this 27. Well, 9 times by 3 gives me 27. I've got a K, but I needed K squared, which means that I need an extra K in here. And I've got an R squared, but I need an R cubed. So I'm going to have an extra R in there. And if I times that together, I'll get my 27 K squared R cubed. So remember, the last thing we need to do is just double check that we've done this correctly. So let's colour coordinate my lines. If I times these two things together, I'm going to get 36 KQR squared. If I times this together, what am I going to get? Well, 7 times 9 gives me, I've got a minus there, so it'd be minus 63 Q squared K cubed R squared. And the last one I need to do is this red line here. And we know 9 times by 3 gives me plus 27. Okay, we've got two lots of these K's. K times K is K squared. R squared times R is R cubed. And as you can see, this is exactly the same as our initial equation. So we can give ourselves a big happy face because we've managed to factorise this and expand it and get the same answer. So this is a very hard question. If you didn't get it first time, I recommend that we retry it and hopefully you'll get it the second time.